Okay. Good morning all of you once again. In a morning class I given 4 properties of alpha, beta, gamma rays. So now I will give remaining properties. Say what is the first one? Alpha properties, alpha decay. So alpha is nothing but the helium nucleus. So that is a 2He4. Same next one, this beta is equals electron. So minus 1 E0, minus 1 E0. So next one is equals gamma, gamma is equals to photons, nothing but electromagnetic waves. Okay. Again, second point, this alpha rays deflected both electric as well as magnetic fields. Okay, both electric and magnetic fields. Again, beta rays also deflected in electric and magnetic fields. Again, next to gamma rays are not deflected electric and magnetic field. Okay, so that's why they are moving straight also, nothing but photons. Okay. Again, third point is very important one. So they can ionize the gas through which they pass. So what is the ionizing power of the alpha particle is equal to, the ionizing power is equal to 100 times of the ionizing power of the beta. So which is equal to 10,000 times of the ionizing power of the gamma. Clear? So this ionizing power is equal to 100 times more than ionizing power of the beta value. Again, next one, 10,000 times more than ionizing power of the gamma. So what about again beta is equal to same statement, same also. So they can ionize the gas. So what is ionizing power of the beta is equal to? So this is equal 100 times more than gamma, and again 1 by 100 times of the alpha also. So this is equal 100 times of the gamma. Again next one, 1 by 100 times of the alpha. So next one is again gamma rays. This ionizing power of the gamma is equal to 1 by 100 times of the ionizing power of the beta, and again 1 by 10,000 times of the ionizing power of the alpha. So next one, again next fourth point, they can penetrate through the matter. So what is the penetrating power is equal to? The penetrating power is equal to 1 by 100 times of the penetrating power of the beta, and again next one, the penetrating power of the alpha is equal to 1 by 10,000 times of the penetrating power of the gamma. Okay, compulsory you have to practice both ionizing power values and penetrating power values. Same again fourth part in this beta also. So they can penetrate again through the matter. So what is the penetrating power of the beta is equal to how much? So this value is equal to 1 by 100 times of the penetrating power of the gamma, and again which is equal to 100 times of the penetrating power of the alpha. See this equation. So penetrating power of the alpha is equal to 1 by 100 into penetrating power of the beta. Clear? So penetrating power of the beta is equal to how much? So 100 times of the penetrating power of the alpha. Same. Again next one, same again fourth point in this gamma rays. So same this also, they can penetrate through the matter. So what is the penetrating power of the gamma is equal to how much? So this value is equal to, so PP gamma is equal to 100 times of the penetrating power of the beta. Again next one, again next point again, this penetrating power of the alpha is equal to 1 by 10,000 into penetrating power of the gamma. So what is the penetrating power of gamma is equal to how much? So 10,000 times of the penetrating power of the alpha. Okay, this is 4 points. Okay, again fifth point, this alpha rays nothing but particles. These are the particles. So these are the particles. These are the particles. They are the particles. So these are they are particles. Same this also, they are the particles. Okay, next one, same this one. This gamma is nothing but electromagnetic radiations, electromagnetic waves. So electromagnetic waves, this wavelength is less than 1 angstrom unit, less than 1 angstrom unit. This wavelength is less than of the 1 angstrom unit. less than of 1 angstrom unit. Fifth point, alpha rays nothing but particles, same this also beta again also particles, again next word gamma is nothing but electromagnetic waves. This wavelength is less than of the 1 angstrom unit. Clear? Again next one, sixth point, the velocity of the alpha rays is equal to the order of 10 power 6 meter per second, 10 power 6 meter per second. The alpha particle velocity is order of 10 to the power of 6 meter per second. The 10 power 6 means how many times of this velocity of light in vacuum? So nearly 1 by 100 times. Velocity of the light in vacuum is equal to 3 into 10 to the power of 8 meter per second. Clear? Okay, but this is equal, alpha is equal to 10 power 6. The 10 power 6 means this is equal to 1 by 100 times of the velocity of the light in vacuum. Okay, next one. Same, this is equal to sixth one. This is equal to 1 by 10 times of the velocity of the light in vacuum. So that means 10 to the power of 7. This order is equal to 10 power 7 meters per second. Or 1 by 10 times of the velocity of the light in vacuum. The velocity of the beta rays is equal to 10 to the power of 7 meters per second. So 10 to the power of 7 meters per second, or 1 by 10 times of the 1 by 10 times. 1 by 10 times of the velocity of the 10 times the velocity of the light in vacuum. So 1 by 10 times into C. So this one is equal to the 1 by 100 times into C. 1 by 10 times into C. Okay, next sixth point. This gamma photons nothing but electromagnetic waves. Right? Do you know this electromagnetic wave speed is equal? This velocity is equal to 3 into 10 to the power of 8 meters per second. 3 into 10 to the power of 8 meters per second. Almost equal to velocity of light in vacuum. Compulsory you have to practice values also, ionizing power value, penetrating power value. So next one is velocity value. So what is the velocity of the alpha rays is equal to, that value is equal to 10 power 6 meters per second. So that means this is a 1 by 100 times of the velocity of the light in vacuum. Okay. So what is the beta is equal to? So 10 to the power of 7 meters per second, or this is equal to 1 by 10 times velocity of the light in vacuum. So next one, gamma is equal to here. This velocity is equal to 3 into 10 to the power of 8 meters per second. Okay. Again, next seventh point. So I write here seventh point. The effect photographic plates same. Seventh are same, the beta also same. The effect taken photographic plates same, this also same. The effect photographic plates. These are the properties of the alpha, beta, gamma rays. So first you have to find out what is the difference of this alpha, beta, gamma rays. Again it is very easy only. Now I am going to explain one important topic in this radioactivity, that is a radio. Completed the? Right now, radioactivity decay law. Remaining applications, remaining sums depends upon this decay law. So radioactivity decay law. First I will explain one example, general example. After that I will explain the decay law also. Suppose in any lottery I will get 1 crore rupees amount. Wait. Again, in this case, in this one, almost all, almost all I will give again 50 lakhs rupees donation to some poor people remaining anyone here. Okay? Next one. So, 1 crore amount, that means almost 50 lakhs or maybe 40 again 60, around 50%, not exactly 50 lakhs here, so depends situation, okay? Next, suppose again, suppose 1 lakh rupees, 1 lakh rupees means I will give again, suppose 50,000 rupees, so 50,000 rupees I will donate this one, okay? Here 50 lakh, second one is 50,000, again next, suppose this is equal to only 1,000 rupees. So 1,000 rupees. So I will give again 5,000 rupees second donation. Okay? 5,000. 10,000. 10,000. 500 rupees again donation here. Okay? Here this donation amount again, last one is equal just small. Okay? 500 rupees. Okay? Again first case is equal 50 lakhs. But this 50 lakhs, 50,000, 500 rupees depends upon the initial amount, okay? So initial amount is more means again, the donation amount is also more. The donation amount is directly proportional to so initial amount also, okay? So maybe 1 crore again I will get 1 crore means I will give donation 50 lakhs. Suppose I will get only 10,000 rupees, 10,000 rupees only. So again, I will 10,000, 1,000. 10,000 means 5,000, again 1,000 means 500 rupees, okay? That means the donation amount is directly proportional to so initial amount, okay? So donation amount again increase means initial amount also more. Suppose initial amount is equal less means donation amount is also less, okay? The donation amount is directly proportional initial amount also, okay? Okay, next one. Suppose this is the one nucleus. Again, suppose this contains again 8. Suppose, okay, number of atoms is equal 8 only, okay? Suppose again after some time, the time is equal to maybe 5 minutes. It disintegrates to again this is equal like first one is equal to 16. After the 5 minutes again it will come to this is equal to 8. So that means disintegrates how many nuclei is equal to 8? Okay, 8. Again, next, again after the 5 minutes, again 5 minutes, I am taking the again equal timings also. Again this is equal again 4. So this part is equal to 4. So what disintegration nucleus is equal, this one is equal to 4. Again next after the again 5 minutes, after 5 minutes here, so this again is come to the 2. So that is equal, disintegration is equal to 2 only. Here this last disintegration is equal to 2, first disintegration is equal to 8. The time should be remain the same. But why this is last case is equal to 8, first case is equal to 8 minutes, first case is equal to 8, last case 2 minutes here. So initial nuclei is more. Okay, that means the disintegration or decay of the nucleus depends upon the so initial nuclei also. Again, same this also, the donation amount is also depending upon the initial amount. So here the 50 lakhs is equal to more again since 1 crore. Here 5,500 rupees less means initial amount also less only here. The donation amount is directly proportional to so initial amount. Same, this also, this is equals to disintegration. The disintegration is also proportional to the initial nuclei also, okay? Suppose here N0 is equal to the number of nuclei. So number of nuclei at T is equal to 0. At T is equal to 0 means this is equal to initial value, initial amount of the nuclei. Okay, now T is equal to 0. Okay, again, next one. Second one is equal to N. So N is equal to number of the nuclei at T is equal to, so at T is equal to T seconds. So this one is equal to final value, okay now? So N is equal to final means sometimes, okay? Same this example also. So initial is equal to 1 crore, okay now? Again, this donation amount is 50 lakhs. Okay, again, next one. Same this also, again, one more example here. So the number of nuclei at T is equal to 0 is equal to initial. Again, next one, the number of nuclei at T is equal to T seconds. After some time, the number of nuclei is equal to N. Okay, so the rate of disintegration dN by dt is directly proportional to the number of the nuclei present at that instant. So this is one simple statement. So dN by dt is proportional to N. So this is one of the main equation. dN by dt is nothing but the rate of disintegration. The rate of disintegration is directly proportional to the number of the nuclei present at that instant. Okay, this is known as radioactive decay law. So it is independent of this physical conditions, maybe pressure, again temperature, again chemical, again composition also. Okay, it is independent of temperature, it is independent of pressure also here. Okay, so dN by dt is proportional to N. What is statement? The rate of disintegration is directly proportional to the number of nuclei present at that instant. Okay, and it is independent of temperature. Next one, the pressure and chemical compositions. Okay, that is not this equal, that is dN by dt is proportional to N. dN by dt is proportional to N. Okay now, so this is one of the main equation. If you know the statement, again this all derivation part also very simple and easy also. So remaining applications, remaining sums depends upon this equation. The next one more thing, coming Sunday syllabus, complete atoms. I think already this one is completed last week, okay, before last week, okay. Again, next one, nuclear physics up to this radioactivity decay law. This decay law means again including sums, including applications also. Okay, so once again, complete atoms. Again, next, so nuclear physics up to radioactivity decay law. Decay law means not this is only this equation. So including application, including sums also. Okay, so this is a statement. So dN by dt is proportional to capital N. So once again the statement means here same as in our mind this example, the donation amount is directly proportional to initial amount also. Here 50 lakhs is more, again 500 also more, compared to this again 1000 rupees, okay. The donation amount is directly proportional to initial amount also, okay. Same this also, the rate of disintegration of the nuclei. The rate of disintegration of the nuclei is directly proportional to the number of nuclei present at that instant. Okay, so already I given one more example also here. Suppose initial number of the nuclei is equal to 16. After the 5 minutes, so again 5 minutes again, this disintegration to again disintegration. So remaining is equal to how much? 8. So how many nuclei disintegration? 8. Okay. Again next after some time again 5 minutes, the number of nuclei is equal to 4. How many disintegration is equal to here? The 4. Okay, again next one more case. The number of again nuclear disintegration is equal to 2, remaining is equal to 2. Okay, so in this case this is equal to 2, this is equal to 8. The disintegration is directly proportional to the number of nuclei present at that instant also. Okay, same the statement. The rate of disintegration of the nuclei is directly proportional to the number of nuclei present at that instant. Okay, so this law is known as radioactivity decay law. So what is the equation? So dN by dt is proportional to n. Again next one dN by, this equation completed. Right, this also n0 is equal to number of nuclei at t is equal to 0. Simply this is nothing but initial number of nuclei at t is equal to 0. Next, capital N, that is equal number of the nuclei at t is equal to t seconds. T is equal to t seconds. In the bracket final. Okay. Now again dN by dt is equal, dN by dt some constant, some constant is equal to lambda into n. That is lambda is not wavelength. One more symbol, lambda is equal to decay constant, write down. Here lambda is equal to decay constant. Decay constant. Sir, why you took minus value? Minus means initial this is equal to, it was again how many? 16. Again next one is equal to 8. So next one is equal to 4. Again next one is equal to 2. So that means decrease only. So decreasing nothing but this is equal to taken as a negative also. So dN by dt is equal to minus of lambda into n. So where lambda is equal to decay constant. Okay. So why we have to take minus means, so this is equal to number of nuclei decrease or time is going on increase. Okay. Again next one. Again, so this dN by dt minus lambda into n, lambda decay constant. So I will let this equation. So dN by n is equal to minus lambda into dt. So dN by n is equal to minus lambda into dt. Right, the next one, taking integration both sides. I love this donation amount. Okay. Pray. No need of 1 crore 50 lakhs this also. After become your MBBS doctor, you have to do free service to poor people. Okay, na? Next one. Silent. So dN, only 1 second. dN by n is equal to lambda into dt. Taking integration both sides. Taking integration on both sides. Taking integration on both sides. So what is the value? Integration of dN by n is equal to say minus of. So integration lambda into dt. what is integration of x dx is equal to the? So this is integration of x dx, x square by 2. But again, this is a 1 by x dx. So integration of 1 by x dx is equal to log x, okay? So log x. So log x, okay? Same, this also integration of n dn is equal to. So this is equal to log n. So which is equal to minus lambda into, the lambda is a constant, since dk constant here. So lambda into integration of dt. So integration dt is equal to how much? This value is a t. The integration of x is equal to how much? This is equal to integration of dx is equal to say x. So integration of dx is equal to x. If you have any doubt, please note the since also. Okay, again some constant is equal to c. So integration of dn by n is equal to integration of minus lambda into dt. Dn by n, this value log n or log exponential e into n. Okay, again minus log e constant, okay, log e into n minus lambda t plus c. Okay, next one more point. Suppose if t is equal to 0, t is equal to 0 means initial value t is equal to 0. T is equal to 0, how many nucleus were there? N naught. So that means if t is equal to 0, then n is equal to how much? N is equal to n naught. Then n is equal to n naught. So what is that equation? So equation 2 which implies, so log base e n is equal to n naught. So which is equal to minus lambda into t, again plus c. T is equal to 0, directly this is equal to 0, again plus c. So c is equal to log base e into n naught. Okay? So at the time t is equal to 0, so how many initial nuclei were there means n naught, okay? N naught. Already I given this matter also n naught. So hence here so log base e. So n is equal to n naught. So which is equal, like this value is equal to 0 plus c. So c is equal to log base e into n naught. Okay? So now again equation 2 which implies, so this is equal to log base e n is equal to minus lambda into t plus c is equal to, what is that equation? So log base e n naught. Okay, you have to substitute c in this above equation. So this log base e n is equal to minus lambda into t plus c, c is equal to this value. Suppose it will come this left side, this become negative also. What is that equation? So log base e n minus log base e n naught is equal to say minus lambda t. So log a again minus log b. What is the formula? Log of a by b. So log a minus log b is equal to log of a by b. If you have any doubt, please note this value also side. Since log a minus log b is equal to, so log a minus log b is equal to, so this is equal to log of, so a by b. Same this equation log of, so n by n naught is equal to minus lambda t. Okay, so now again is one more equation. So log of n by n naught is equal to minus lambda into t. Shall I have this one the integration? So this also log a minus log b is log of a by b. Okay. Again, so log base e n by n naught is equal to lambda into t. Okay. Again, now again n by n naught is equal to, so e to the power minus lambda into t. So n is equal to say n naught into e to the power minus lambda into t. So please note this equation. So n is equal to n naught into e to the power of minus lambda into t. Okay, e means exponentially. exponential decrease. The number of nuclei always again decrease exponential with respect to time. So this is one of the final equation. So first equation, this is the main equation. From the equation 1, we have to derive that. So n is equal to n naught into e to the power minus lambda into t. So this is equal to equation 3. Okay. Once again the statement and this equation. So if you know the statement, this equation, so remaining applications very simple and remaining graphs also very simple. Okay. First one in your mind, one example also. Which example? So this is a donation amount also. Okay. The donation amount is directly proportional to initial amount. Okay. Again. So that means initial amount was more, means the donation amount also more. Same. This is equal to n naught is equal to number of the nuclei at a time t is equal to 0 seconds. Initially this number of nuclei is equal to n naught. Again after the after the donation, how much amount? So that is equal to n. So after the disintegration, again how many nuclei are there? This is equal to n. So n is equal to number of the nuclei at time t is equal to t seconds, final value. So now again statement, the rate of disintegration of the nuclei is directly proportional to the number of the nuclei present at that instant. Clear? So dn by dt is proportional to n. It is independent of some physical conditions. What are the physical conditions here? It is independent of the temperature, it is independent of the pressure, and also chemical compositions also. Okay? Again, next one. So our statement, so dn by dt is proportional to n. Again, dn by dt is equal to some constant into n. So what is the some constant is equal? This is equal to minus lambda. The lambda is not wavelength, okay, now like waves, okay. This is a decay constant, okay. So decay means don't write d. Okay, this is a k, not decay here. Okay, d is cay. Okay, decay constant. So lambda is equal to decay constant. Again, so why again we take the minus means again when the time is increase, the number of nuclei also decrease. So here lambda is equal to decay constant. So again, so dn by n is equal to say dn by n is equal to minus lambda into dt. So taking integration both sides. So integration of dn by n is equal to minus of lambda into dt. Okay. So already you know this formulas also. So integration of x dx is equal to x square by 2. So integration of 1 by x dx is equal to log x. So this is equal to log base c into x means n. So which is equal to means lambda into t plus c. C is a constant. Suppose here at a time t is equal to 0, the number of nuclei is equal to n naught. Okay, that means n is equal to n naught only. So n is equal to n naught. Again, log base c n naught is equal to 0 plus c. So why we take 0 means t is equal to 0 seconds also. So now again equation 2 which implies, so log base c n is equal to minus lambda into t plus c is equal to how much here? So log base c n naught. It will go to this side, this become negative. So log base c n minus log base c n naught is equal to minus lambda into t. So already we know one of logarithm formulas. So log a minus log b is equal to, so log of a by b. Same this also log n minus log n naught means so log of n by n naught. So log base c n by n naught is equal to minus lambda into t. Again one more equation. So n by n naught is equal to say e to the power of minus lambda into t. Okay, exponential value. So n is equal to n naught into e to the power of minus lambda into t. So that means the number of nuclei decreases with time factor, okay, as exponential also. Okay, exponential decrease. So n is equal to n naught into e to the power of lambda into t. So tomorrow I will give this graphs also, graphs, and again next one is activity, again next one is half lifetime, that equations also. Okay, right, thank you all of you. Stop.